Welcome to this tutorial video on how to start up the beautiful Boeing 737. My name is Edwin, also known as Red Wings 27. Today I am going to teach you how to get this aircraft from being completely powered off to ready to taxi. I will include how to set up the Flight Management Computer, or FMC, as well. Without any further ado, let's go inside the cockpit. This is the flight deck of the Boeing 737. There is currently no power in the aircraft whatsoever. Let's start by giving the airplane electrical power first. So the very first step in this aircraft, just like most other aircraft, is to turn on the battery. Keep in mind that the battery is a form of direct current, or DC. That means that once the electrons leave the battery, they do not return to the battery, therefore discharging the battery. An analogy I can give you is, imagine having a cup of water and you slowly start pouring that water into the ground. Once it falls, it cannot come back, and eventually your cup will be empty. Same thing happens to the battery. So the way to fix this is by acquiring some form of alternating current, or AC. In this aircraft, we have a couple of options. First, we have the ground power unit, or GPU. Second, we have the auxiliary power unit, or APU. And last, we have the engines. For the purposes of this video, I will be using the APU. Also, American Airlines in the real world also mostly uses the APU. There are advantages and disadvantages to the APU and the GPU. Okay, too much talking. So first go to the overhead panel and locate the electrical panel. You will see this switch labeled BAT with a black cover. Simply close the cover and the battery will turn on. As you can see, not much will happen. That is because the battery alone isn't enough to power up an entire airplane. Also, here in the DC amps side, it shows -74, which means we are now discharging the battery. On the AC side, you can cycle the switch to see whether or not its respective source of power is charging the battery. You can view the APU, or engine amps, for example. Before starting the APU, we must conduct an APU fire test. The last thing we want is the APU turning on fire and the alarm doesn't work. So here comes the APU. The APU is a self-contained jet engine located at the tail of the airplane. This jet engine uses fuel, and it will provide us with electricity for the aircraft and also pneumatic or pressurized air for air conditioning, and also bleed air to spin the main turbines for startup. So first turn on the left aft fuel pump, since the APU runs on fuel. And then put the APU switch on the on position for a second, and then on the start position. Sounds amazing. And now we will wait for the APU to start up 100%, and then you will see the generator lights come on. Once they come on, flick both of these switches to the APU on bus. There you go. Now you can see and hear the rest of the systems come on. So now that the airplane has AC current, we don't have to worry about the battery discharging. We can continue doing the flight deck preparations. So now we are going to turn on the IRS switches. No, I'm not talking about the Internal Revenue Service. I am talking about the Inertial Reference System. This is basically like turning on the GPS, if you will. The IRS tells the aircraft where it's at in space. This is important because if the plane doesn't know where it's at in space, it cannot determine where to go, or its heading or altitude. So we will turn both of the IRS switches located on the upper overhead panel to the nav position. This knob will tell us how long it will take for the IRS to align and be ready. In this case, approximately 9 minutes. Now we can close and arm the emergency exit lights. And this doesn't really do anything, it's just a chime sound, but why not? Now we make sure the nav or position lights are on if they aren't already. This lets people know outside the aircraft that there is people inside turning on the aircraft, and also tells the position of the aircraft in relation to the person looking at it. Also the logo lights if required. We can also turn on the window heat so condensation doesn't form. Now let's turn on the air conditioning. First turn off the engine bleed air valves and then turn on the APU bleed air valve. This will allow the APU air to pressurize the system. Then we turn on the PACs or pneumatic air conditioning kits. Okay, so now let's do a couple of tests. First, let's do an oxygen mask test for both the captain and first officer. Now we will do a cargo fire test. Now a squib test. Then the autopilot disconnect lights test. And test all the lights in the cockpit. Let's also test the flaps lights. Also, let's test the overspeed sounds and the stall shakers in the yoke. Now comes the most complex system in the aircraft, the FMC. FMC stands for Flight Management Computer, also referred to as the FMS, or Flight Management System. This such system is the brain of the aircraft. It is a computer in which you communicate with the aircraft. You use the FMC to tell the aircraft the flight route, as well as other very important values such as fuel, weights, weather, and more. I will show you how to program it if you don't already know how. First, you will need a flight plan from SimBrief. This will give you all the necessary information you will need for your flight. Today we will be programming a short flight from Los Angeles to El Paso. And I am using the WinWing FMC, so you will not see my cursor. So first go to FS Actions. Go to Fuel. And then copy the block fuel amount from the window on the right and paste it under total pounds. The plane now has the amount of fuel we need for the entire flight. Now go back to Menu and then press FMC. Here is the information we will input into the FMC. Clear the message on the scratch pad using the CLR key and then go to the Pause Init page. Then enter the airport code of the airport where your airplane is at, then paste it next to reference airport. Now press the next page button and copy the left GPS position into the scratch pad. Once copied, press previous page button then paste it on the empty boxes. This will start telling the computer your position. As suggested, press the key next to where it says route. Now paste your airport code again underneath origin. Now type your destination airport code and paste it under dest. Now enter the information required, such as runway and flight number. Great, now press the departure and arrivals key above the letter A. Next to the departing airport, in this case LAX, press the DEP key next to KLAX. Based on the flight plan on the right, we will be departing via runway 25 right with the dots to departure. Since runway 25 right isn't showing on this page, press the next page button to find it and then select it. Also select the dots to departure. After that, we have the scenery transition, so select scenery. Once we are finished with that, press the route page as suggested, then press the next page button. And then the next point is going to be DCT, which means direct, to BLH. Then paste it under scenery. From experience, the BLH we want is the top one. After that, we have the Juliet 169 airway. So we type 169 and we paste on the left side under where it says direct. And we just continue doing this with all the waypoints and airways. Now this is the last waypoint before the arrival. The way you'll know this is because after the T's waypoint, we have Molly with a 5 on it. A name with a number on it indicates a departure or an arrival. So the way you select your arrival, in this case Molly 5, you go back to the departure and arrivals page, and next to KELP you select arrival. Then you simply look for Molly 5 and select it. And our last waypoint before Molly 5 was T's, so you select it so that the arrival and the last waypoint can be connected. After that, you select your arrival runway, in this case is runway 22, with the ILS approach, so you select it. You then press the legs page button, and here you will see all your waypoints for your route. And all you are looking for is either vectors or discontinuities. These two are going to leave a gap in your route, so we must get rid of them if any. So right at the bottom you can see an empty box that says then. That is a discontinuity, or basically a gap between your waypoints. To get rid of the gap, you simply go to the waypoint after the discontinuity. In this case, you press next page. Then the fees P waypoint is after the gap, so all you do is select fees P and you paste it onto the empty boxes on the previous page. Now you got rid of the gap, so you just continue looking for any gaps, if any. And it looks like there are no more gaps, so now you press activate and then you press the execute button. Nice! So now your flight plan is active, but we are not finished yet. Now press the init page and we will now deal with some performance numbers. First, we will enter the zero fuel weight, or ZFW. All you have to do is press the empty box under ZFW and it will automatically give you your values in the scratch pad. You then simply paste it on the ZFW box. Next, we grab our reserves fuel, which is on the payload tab on the right, and we look for FinRes plus alternate. The amount of fuel is 44.15, so we round it up and we get 4.4. Next is the cost index. We go back to summary and we look for CI. In this case, it's 13. After that, we need our cruising altitude. In this case, is flight level 350 or 35,000 feet. So we just simply type 350. Then you press the execute button to confirm, and then you press the N1 limit page. So here we are going to derate the engine. meaning we make the airplane think it has less powerful engines than it actually has. This will make the engines reduce wear and tear and also save fuel. You only do this if the runway isn't abnormally short. So I'll select takeoff -1 and climb -1. And now we move to the takeoff page. So first we tell the plane the degree of flaps we'll use for takeoff, so in this case 5. And then same as the 0 fuel weight, we select the CG key to get our center of gravity percentage, and then we paste it. Notice that we also got our trim value. We will use this later. Then on the right side you see V1, VR, and V2. Simply press the keys next to it to paste the V speeds. This will tell you when you can no longer abort a takeoff, which is V1, and when you can rotate the nose up during takeoff, which is VR, and finally the minimum speed with only one engine running, which is V2. Okay, so we are pretty much finished setting up the FMC. Now let's check that our route looks good on the map. And as you can see, the IRS is aligned, so you have more information in the displays. So move this knob to plan mode, and we can also zoom in and out with this range knob. So using the FMC, we can press the step button to step through the waypoints. It's all looking good, so let's go ahead and now set up the autopilot. First, let's turn on both of the flight directors. Now we enter our cruising altitude, which is 35,000 feet. Then we enter our runway heading, which is 251. We then turn on the VNAV and LNAV buttons. We enter our V2 speed, which is 151 plus 10. That's 161. And that is our autopilot and FMC set. Now let's just enter our cruising altitude on the cabin pressure, and then we can start preparing for pushback and engine start. Now let's do a terrain collision avoidance system, or TCAS test, and then a verbal warning test.
TCAS test. Pass.
Glide slope. Pull up. Wind shear. Wind shear. Wind shear. Terrain. Terrain. Pull up.
Airspeed low. Airspeed low.
Great, let's move on. We will now get ready for pushback and start, so let's turn on the fuel pumps. But first, let's see in what fuel tanks we have fuel. So we do not have fuel in the center tanks, so we will not turn on the fuel pumps for those. So we will now turn on the anti-collision/beacon lights to let the ground crew know we are about to move and to be aware. Let's not forget the seatbelt signs, and also let's call the ground crew. We can now turn on the electric hydraulic pumps. And we must turn off the air conditioning so that all the air goes to the engines for startup.
Hello, Captain. We are ready for pushback. Departure checks completed. Bypass pin inserted.
Let's set the engine igniters to either the left or right instead of both, so we can preserve the longevity of the igniters. I will use the right igniters.
Release parking brakes, please. Commencing push. All engines clear. Start at will.
So we will start engine number 2 first by putting the engine starter on the ground position. Then we wait for N2 to rise between 20 and 25%, and we then introduce fuel into the engine. There is 20%, so we move this lever up. The switch will automatically kick back to auto once startup is complete. We then put it to continuous ignition. We check that the engine generator is in fact working.
Please set parking brakes.
And then we put the engine generator on bus.
Waiting your confirmation for a good engine start.
We now repeat the same process for engine number 1.
Cockpit to ground. We have a good engine start. You can disconnect.
Now that both engines are supplying electricity and air, we no longer need the APU. So we will turn off the APU bleed air, turn on both engine bleed air valves, turn on the
Unlocking gear.
packs again, and we then shut off the APU. Perfect. Now we turn
Left
on
is
the
clear,
fuel
right
heats
is
and
clear.
turn on the yaw damper. We will now put the flaps down to 5. And let's watch the flap indicator go down as it should. We can now arm our auto brakes by putting them on the RTO, or rejected takeoff position, so that in case we have to abort the takeoff, the brakes will automatically apply to the max. Also, now you can test your flight controls by pressing the system button, but for whatever reason, the flight control indicator isn't showing in my airplane. Let's not forget to trim the elevator, so here it shows 5 units. So let's trim it now. And now let's just turn on the TCAS to TARA. And that's it. You are now ready to taxi to the runway. I hope you found this hopeful. If you like the quality of this video, please consider following me on Instagram, where I constantly post high-quality reels of the simulator at redwings_27. Also consider subscribing to my